Hey, what's going on? It is your boy Jay Bailey here, and I'm back with yet another video. And today we're gonna do a Windows challenge, but you see I'm on my Kali box here. Windows VM is acting kind of funky right now, so luckily this challenge is easy enough for us to analyze in Windows. We don't really need to do any debugging, so we can just stick to our Ghidra, and we'll use one to run the binary to test our hypotheses. Anyways, this person, it was his first crack me that we had to find the password to gain access. And this is rated level 2, so it should be pretty easy. So let's go ahead and get started here. I will run file on this guy, but it's not going to give us much information here. It just tells that it's a 32-bit binary. But other than that, it says it's a Windows executable, and that's pretty much all you get from running file on here. Usually I run detect it easy, but I have a hard time getting it installed on my Linux VM, so I'm not going to worry about that. Let's just go ahead and look at the strings really quickly. Let's see if there's anything in here of interest. Did I make a mistake here? What's going on? That's I have to actually tell it what to put the strings in there. All right, there we go. Here we go. Okay. Let's see. We can scroll down a bit here, and we see this looks like it's going to be the prompt here, or like the prompt, like the usage message. This is the wrong password. If we get it wrong, access granted. And this looks like it could be a password. Most likely not. I mean, this was a pretty easy challenge, so they could maybe just hide it in the strings. Let's go ahead and see if we can copy this password here. And let's go ahead and run the binary. We're going to use one to do that, and we pass it our parameters, and we're going to have to give it some quotation marks like that. And see what we got. And of course not, right? I mean, we didn't really expect that to work, but you never know. I mean, sometimes we get lucky. So let's go ahead and start our sudo C. All right, and then we're gonna go ahead and start up Ghidra. All right, that took longer than I expected. So let's just go ahead and jump to the main function. And so this binary, it was compiled with min.gw, and that's somewhat important. It's gonna and it's gonna be a little bit more apparent why it's important later on. But something that the way it was compiled, it kind of dictates how we're gonna have to develop our solution just a little bit. At least how I develop my solution. Anyways, so let's go ahead and go to the main function here, and we scroll down, and then we see these underscore main here. We don't have to worry about that. That's a min.gw thing, and I honestly don't really know exactly what it does, but it's something that we do not have to worry about right now, because this challenge isn't that intense. So we can pretty much ignore that part there. So we see the first thing that it does is going to compare argc with 2. So it's going to say if we gave it another argument or not. And if it's not 2, then we see obviously we jump down here and we print out the usage message, right? So let's go ahead and code that up really quickly. So if argc is not equal to 2, then we do printf. I'll just say usage because I don't want to write the whole thing out. And then return 0. All right, so let's go back up here. And let's go back up here. All right, and so then we see we're grabbing argv, and we've seen this before where it adds 4 to that value, so it's pretty much indexing argv there. So that's argv sub 1, and then it gets the actual contents of that, so what we actually typed in. And then remember, this is a 32-bit binary, so parameters are going to be passed on the stack. So this right here is going to place our argv sub 1 on the stack, and it's going to be a parameter to the strlen function here. And that's all. That's going to be the result of this guy here in this local 14. So let's go ahead and write this out. How that's going to be. So it's going to look like we're going to call this len user input is equal to strlen of argv sub 1. And we can we can kind of ignore this for the moment here. So let's not take a look at that. But let's go ahead and rename this guy here to len user input, and one too many L's there. All right, and so then let's see what happens next. So now we're going to load up our user input, the length of that, into EAX, and we're going to put that into this malloc function here. So we're pretty much going to malloc the length of our user input, and we're going to store that into this variable here. And we're going to call this, I think we're going to call this password here. Let's do that. Let's call it password there. And so that looks like pretty much in C is password equals to malloc of len user input. That's all that's doing there. All right, so then finally we're going to grab our argv again. We're going to get argv sub 1 there. We get the contents of that again, and we store that into this guy here. So this is going to be local 2C is going to be our actual user input here. All right, and then what's going to happen here is we're simply just going to copy our user input into this password variable. That's what this is doing here. It's loading up our user input into loads up the password into on the top of the stack. And actually, this right here is going to be argv sub our ESP plus 4, which will be if I Control Shift G on this instruction here. Let it do its thing really quickly. Come on, come on. Not sure why that took so long, but you see this is ESP plus 4, and this will be obviously ESP, so ESP and the ESP plus 4. Those are going to be the two parameters on the stack. So we're pretty much setting our user input, and we're going to copy our user input and put it into the password here. So let's go ahead and take a look at this here. Stir copy password, and then user, oops, and then user input. Oh, no. Oh, I guess I never defined a variable there. There we go. All right, and so then we see our user input gets assigned to this hex1c variable here, and then similarly we're going to see it calls this hash function here, and we're gonna have to take note of the fact that our user input is now hex1c here, and then we're going to call hash on password and user input. But I'm just going to say is 0hex1c just so we can remember what that is. And this is essentially our user inputs. I'm just going to call this, I'm going to say that's our user input that's being passed into there, just so it's a little bit clear what's going on. All right, so now let's go ahead and take a look at what's going on in this hash function here. So we're going to say again user input, and is 0hex1c gets passed into there. All right, let's take a look at the hash function. All right, so see, we see we're going to take our param2, which is hex1c. So let's go ahead and rename this hex1c, and then it's going to load it up onto the top of the stack. And you can ignore this local 6c here. It's similar to what we did in the last time. It's just putting this on top of the stack so it can be called in this srand function. So srand is going to have a static seed, right? And what that means is that we can, it's not going to be a truly random number. Whenever they call random, I mean, I assume they're going to call random at some point. That means we will be able to know what the values of those rands will be, because we can just call rand as many times and it'll generate the same numbers each time it's called. And that's after every time you even run the binaries again. So if I were to run it once, it'll generate some numbers. If I run it again, it'll generate those same numbers. Right, and that's because we're using this static seed here. So this is going to be kind of like a pseudo random number here. Anyways, we don't have to worry about that right now. So then we take our param1 here, and again it's going to be our user input. And then we're going to load up that into strlen, and that's going to be replaced in this result here. So again, it's going to be len user input there. Alright, so now we're going to have, again, just like the last one, len user input is equal to strlen of user input there. Alright, and so then let's see what happens next. We're going to, again, malloc, create another malloc here. And this is going to be another sort of string here. And I think this is going to be, actually going to be some type of password. Let's just say password again here. I'm forgetting exactly what I named these in the previous run, but that's okay. All right. And then we see we're going to load up our 0 into this local 10 variable, and then we see this unconditional jump. So this is going to be I, because we know that that's usually what happens. So it's I equal to 0. If we jump down here, we see I because compared to len user input. And then, yeah, so this is going to be a loop here. So it's going to be while I is less than 0. Actually, first we have to say I equals to 0. While I is less than, not 0, but len user input, we're going to do some stuff. Let's figure out what's going on. All right, so we jump up here, and this is where it gets a little bit confusing. And I think even Ghidra got a little bit confused with this as well. And I'll show you that probably around the end of the video about how Ghidra got a little bit confused on. Yeah, and I'll show you probably around the end of the video about how Ghidra got confused, because I even got confused myself. But anyways, let's go ahead and just kind of step through this line by line. So first, EAX is going to be set to I here, okay, and then EDX is going to have this LEA instruction here. So it's going to calculate EAX times 4, so that's I times 4, and then plus 0. We're just going to ignore that part because we don't care about that. Plus 0 is not going to do anything. All right, and so then what happens? It loads up password into EAX, and then we're going to again call LEA on EDX plus EAX times 1. And that's what EBX is going to be equal to. Is equal to EDX plus EAX times 1. And so then we can just sort of say that's I times 4 plus password. Now this looks a little, oh sorry, plus password. And actually I'm gonna have to rename this variable because that's not actually the password, as we'll see in a little bit. All right, so this looks a little bit strange here, what's going on right here. But let's go ahead and continue really quickly and see what else is going on. So then it's gonna call the rand function here, and it does some stuff here, and all this is gonna do is pretty much gonna mod the result of rand. So it's gonna be rand mod 10. That's all these instructions here are going to do there. And the reason why I know that because I don't know how to decompile this nonsense, but I had Ghidra do it for me, and it's rand mod 10 there. And then it's going to assign that value into this EBX variable here, and actually the result of that. So, and it looks a little confusing the way Ghidra is or the way this assembly looks, but what I gather though is that this is a that password is actually some type of an array or a structure or something of that nature. And if we do password sub I is equal to this, I think this makes a lot more sense than what Ghidra's gonna. What I'll show you that Ghidra came up with later on. And you can actually index a variable like this. So that, I mean, I don't think it's that far-fetched to say that this is some type of an array. And the reason why it's multiplying it by 4 is because each element in this array is 4 bytes long, so it has to get to the next byte. So then it makes sense of why it's doing that. In this rand mod 10, you see that's all this result here is rand mod 10, and that gets stored into EDX, and that gets stored back into this EBX register. So all of that just to have this one line of code right here, and then we're just gonna do I++. All right. So that's all this loop here is going to do, if I'm not mistaken. And yes, I'm not mistaken. So that's all this loop is going to do. So it's pretty much setting up this password with values. And as we'll see later on, that this isn't the password, these are actually keys. At least that's what I'm going to call them. So let's go ahead and rename this to key. And again as well, rename this to key. And we're going to rename it in Ghidra to key. All right, so let's go ahead and continue. So after we do that loop, we're gonna go to another loop, right? So we see hex 0s being passed to stored into hex 14. So this is gonna be J. We can have the same variable name. And then let's see, we jump down here, and we're gonna compare J again to user input. So it's pretty much the same thing. So let's go ahead and get out of this loop here. So J equals to 0 while J is less than len user input, and we're going to do some stuff here. And let's see what we're doing here. So we jump up here. And then this is something that we're kind of more accustomed to seeing, right? So we see user input is actually what we typed in. And we see J is going to be stored into EDX. And then we see this add instruction here. So it's pretty much going to be user input sub J, right? And then we get that actual result and we store it into EAX. And then we're going to put that into this local 20 variable. So that's pretty much saying we're going to do, we're just going to say, I'm just going to call this like a letter. It's getting a letter from our user input and storing it into this variable here. So we're just going to rename this to letter. And my variable names are not very great, I know. But, I mean, it gets the job done. All right, so then what happens next? So we see J here is getting stored into EAX again. And similarly to what we saw earlier, right, we see J times 4 plus 0, right, that's stored into EDX. And then again, we store this key variable into an EAX, and then we add these two values together. So again, this is why kind of somewhat confirms what I thought earlier, which is why this is going to be some type of array of like integers, because it does the same thing. It's indexing the same thing again. So I'm gonna say this is key sub J, and oops, and let's see what it's doing with this guy here. Let's see. So it gets that in there, and then it adds it to letter here actually, right? So and that's gonna be letter plus equals, because that's what that's just doing there. So it's gonna be pretty much letter plus equals to key sub J there. And then let's see what happens next. We store that into ECX, move that into ECX, right? So letters or ECX is going to have letters plus equals key sub J. And then we store this new kind of variable here, this EBP plus hex 4E. That's going to be another type of an array, and I'm going to rename this guy here. Whoops, we're going to call this new user input, I guess, because that's what it's doing eventually, right? So we have EDX here, and we have J, and then we're gonna get new user input sub J, and then we're gonna store that result back into our new user input. So all that's to say is gonna new user input sub J equals to letter. All right, and so that's all that is doing there, and it's gonna, I guess I can't forget the J++, otherwise it'll be an infinite loop, and that's it for that while loop there. All right, and so then we'll see what happens next. We're going to take our new user input, we're gonna take our length user input, and then we're going to essentially assign 0 to that, right? So we're gonna take new user input sub length user input, so get the last a character or last element in the array, and pretty much assign the null character to that, so we can null terminate the string. And then let's see what happens next. We store this into our local 68 variable, and all this is really doing is, again, it's going to store copy into this hash password string here. And so this is probably some like global variable that they use so they can pass it around easily. So all we're going to do say here is after this loop ends, we're going to do so new user input sub len user input equals to, I'm just going to say like that. And then we're going to stir copy this underscore hash pwd with new user input, just like that. And then it exits the function. All right, so really quickly, I want to show you what Ghidra kind of came up with. Let me get rid of this thing here because we don't really need this anymore. So I want to show you what Ghidra came up with, and unfortunately, I don't know how to fix Ghidra's mistake, but I think it was a mistake on Ghidra's part. So let's go ahead and look at the decompilation. I know it's a cardinal sin on this channel, not really, but all right. So let's go ahead and pull up our decompilation as well. Whoops. All right, so we have pretty much everything right here. So we see the SRAN and the is hex1c there. Get the length of the user input. Get the key malloc. Oops, I actually did forget that it's well, the way I interpreted it as was actually times 2 times 4 like that. And actually, I'll go to this instruction here and show you what that is. Yeah, so I totally missed this part here, where it loads our length user input into EAX, and you see it does this SHL instruction with 2. And so to me, that I'm saying that tells me that it's going to take our user input and multiply it by 2 to the 2 power, right? And so that, I think that's all that's doing there, and I think that's pretty much equivalent to what that is there. So we set I, and here's where Ghidra kind of messes up here. It defines this variable pi var, and you see here it does exactly what I did in my decompilation here, right? So I didn't quite show it here, but I think I had it earlier on when I said I times 4 plus key, right? I had that earlier on, but it's assigning that to this pi var value, and it gets the random number, and then it mods that by 10. So that's this one here is pretty much I var right there, and it assigns it to this pi var here. But you see this pi var is never used anywhere else throughout this function, but this key variable is used throughout this function here again. And so that's why I think Ghidra somehow messed up this decompilation, and I don't know how, and I don't know how to fix it. But you see, I think that's why this is supposed to be key sub I equals to rand mod 10, and not this nonsense here. Oh, it's not complete nonsense, but it's kind of nonsense. It's a little bit of nonsense, right? Because it doesn't really make sense. Because we're declaring this variable, but we're never using it again. But then this variable here never gets assigned anything, but we're using it later on. So again, I just think Ghidra kind of got messed up here, but that's okay. We don't have to worry about that. We were looking at the disassembly anyways, but that's just to show you that sometimes decompilation is hard, especially to do it in an automated fashion. We're doing this manually, so it's a little bit easier for us, but Ghidra has to do this automatically without human interaction. So we have to kind of cut Ghidra some slack, but again, it just kind of shows just how difficult it is to decompile things. Hey, what's going on? This is Future J Bailey here, and I actually made a mistake when I about something that I said, so I'm going to correct that right now. Just right now, I said that this particular code here is incorrect, and that Ghidra made a mistake in the decompilation, yada yada yada. It's not really a mistake. This actually is correct. It's just I just didn't understand what was going on, and I think that was the issue. But first, before I do that, let's go ahead and fix this variable first here. So they type this as a void pointer, and which makes sense because malloc does return a void pointer if I'm not mistaken. So it makes sense why Ghidra would do that. But let's go ahead and retype this as an integer pointer, and you'll see that it cleans up the code quite a bit. All right, so it looks a lot cleaner now, right? So we see key plus I, and then we see down here key sub j. All right, it looks fine to me. Now, when I said earlier that, oh, this pi var 1 variable is kind of useless because there's nothing, it doesn't get used ever in this function again. And then I don't know if I mentioned it, but like this key variable here, it never gets assigned to anything. So what's going on? But what actually is happening though is that what I failed to realize is that pi var is actually an integer pointer. And what this is doing here is that it's going to point pi var to key plus I. So they're going to point to the same memory address. And then when we do this assignment down here, it's going to say pi var 1 is going to be equal to I var mod 10, right? And so that's going to store that into that memory address. But remember, key plus I and pi var 1 are pointing to the same memory address. So when we dereference this here, we're essentially dereferencing key plus I. So that this is an actual valid instruction, valid code. It just makes it a little bit hard to understand. That's just kind of, you have to kind of remember, what's going on, how to kind of keep in mind that pointer arithmetic can be a little bit tricky sometimes, as it was tricky for me. And so the reason why it does this instead of doing it the way I did it, where I said key sub I equals to I var mod 10, is because Ghidra right now can't convert this disassembly to that notation that I had earlier, the key sub I equals to rand mod 10. It can't just do that by automatically, right? And so it's just an issue that Ghidra has at the moment. But it's okay. I mean, we just have to live with it right now. So if we can just rename this to key next, and that'll be just fine. right? Because this is essentially what that is. It's just assigning the next value for our key, and that's all fine and dandy. Now, someone pointed out to me that there is a potential buffer overflow in this code, and I actually didn't notice it at first. And I'm gonna give you a second here. You can pause the video. I want to see if you can find it yourself, because I actually did not realize that there was a potential buffer overflow, and I think there might be. So I'll give you a second. You can pause the video, and I'll come back. All right. So it seems like you're good to go now. So if you didn't find it, it's okay. I didn't recognize it either. But the issue lies in this part here, where it says new user input is going to be equal to this letter here, but it's also dependent on the user input sub j, and that's also dependent on the length of the user input. Now we control the user input, and if we go back to the function that calls this, the user input isn't really sanitized at all, right? So if we go back here, we see that it's going to be the length of our user input, obviously, right? And then we're going to allocate some memory to this, and it's going to be the size of whatever you typed in. It's going to allocate that memory, which is good. That's what we want to do, right? And then we're going to copy whatever you typed in and paste that into our user input here, our destination. And so assume that we typed in 1,000 characters. This is going to be 1,000 bytes long, right? Now, if you go in here, there's nothing here that's going to make our user input smaller. So it's going to potentially be problematic when we get here, when we're actually copying our bytes into this new user input variable, because, well, it's only 50 bytes long. So we could potentially do a buffer overflow. I'm not sure. I haven't tried it yet. Actually, we can look at it really quickly right now. If we do, because I have wine on here. Fine. Okay, there we go. And we're just gonna give it a whole bunch of A's. Not entirely sure how many A's. I'm just gonna put a whole bunch in here, and we're just gonna see what happens. Because yeah, it's just something that's interesting, and I didn't notice it at first, so it's just kind of fun to try. And I mean, that should be enough A's. I just like to be safe. They say smash a stack. I like to smash that stack. So, all right. So I think that's pretty good enough. So let's go ahead and execute and see what happens. All right. So we see there's an unhandled page fault on read access on here. We do see 41 there, which could be an A. That is A, but I don't know if that's a result of what we typed in. Let's just go ahead and close this, and it just prints out this stack tree, which is really nice. And on the stack, I actually do not see a bunch of A's, which is interesting. But it does tell you where it actually failed. So it failed at this memory address, 401508, which actually is 401508 right here. And that's actually up here, isn't it? Somewhere up here. Oh no, wait, is it down there? All right, where the heck is it? Yeah, it actually might be somewhere around here. Let me see. Let me go back here. B5. Yeah, I'll have to do a little more digging in here because I'm not entirely sure where this is. But let's see. We do see. I think we are in this loop, right? Yeah, so we are in this loop here. Yeah, so we are in this loop. So I think this is about the area. So we may be onto something here. I don't know. Like I said, I'll give it a shot, and if I find anything interesting, I'll update you all. But yeah, maybe perhaps unintentional buffer overflow on behalf of the author, or maybe that is the whole point. I don't know. But anyways, the real thing is I wanted to show you is that I was wrong about this. I'm wrong a lot of times. It's okay. But yeah, so I just want to make sure that I got that cleared up. Anyways, enjoy the rest of the video. All right, so now we know how our user input is created, right? So we're going to we know how this new hash password is created. So it's going to generate 10 or length user input random values, right? Because it's not really random. and it's going to pretty much add those to our letter. So this, to me, this looks like it's some sort of shift cipher, right? So if random number was 5 and our user input was P, it's going to increment P 5 times, or increment P to 5 characters, right? So it'd be P, what A B C D E F G H I J A B C D E F G H P Q R S T U. So it's gonna be U. I know I can't do alphabetic math in my head. Okay, I'm sorry, y'all know this already. Anyways, so that's all it's doing. It's gonna do that for each character in our user input. It's gonna randomly shift our characters in there. So we know that, and we also can figure out how it's doing that, because it's not gonna be truly random because it has a static seed, so we can calculate deterministically every single value that's gonna shift our user input. Before we get a little bit too ahead of ourselves, let's go back to the main function, and we're gonna see if there's anything else that we need to worry about here. All right. So then we see we get this value here from memory, and we recognize this from earlier, right? This is that number, that are those sequence of bytes that we saw earlier, and we stored that into this local1c variable. So what we're gonna do here is we're gonna change this to, I'll just say hashed password here. And then we're going to pretty much do a string comparison of the hash password that we just kind of got from our that hash function and this hash password here. And if they're equal to each other, then we were, let's see. Okay, and this is also strange. I'm not sure why it does the same comparison 3 times in a row, but it does the same comparison 3 times in a row, the exact same comparison, and then eventually it's just going to say access granted if it's correct. Otherwise, it's going to say wrong password. So we're going to pretty much say if underscore hash password, actually this is stir compare with a hash password, and hash password is equal to this nonsense here. Let's go ahead and copy those. Then we're going to say, and this is going to be equals 0, 0, right? Yeah, stir. Okay, that's good. Then we're going to say printf access granted, and then otherwise else it's wrong password. All right, and so and that's pretty much it for that, right? And so now the question is, so what's the actual password then, right? And I don't think I have it on my Kali machine. Let me check and see if I hit it somewhere. Okay, no, I did not. All right, so let's go ahead. Let me pull this up really quickly here. All right, and we're going to keygen.c. All right, so I wrote a simple C program that's going to pretty much take the hash password and just do the exact opposite of what the actual program did to calculate our random number or our password, right? So I load up the new hash password, or the hash password in there. I get the random number. I see srand with this, and then I pretty much loop over the hash with and I perform a minus instead of an addition there, and just add the password. And so at the end of this, it's going to give us the actual password. I know this isn't kind of the best coding style, but it works. Let's go ahead and compile this. Actually, and this is another reason why I think I mentioned it earlier, but we have to compile this with min-gw, otherwise it's going to throw off the random number generator. All right, so now we have our keygen.exe. So now let's call it. And you see, I printed out the random numbers just because it wasn't really necessary, but these random numbers will be the same every single time. But then we see to print out the actual password easy. let's go ahead and copy this, and we're going to test it in our actual binary here. And there it is. That's all there is to it. All right, so just a quick recap here. So we figured out that it's doing a very basic hash function to hash our password, and it's using the static seed, and so that's going to mean that the random numbers are deterministic. So we can easily just do this, calculate the random numbers, and get our password, get the password actually. And yeah, so fairly simple challenge, but I thought this was pretty interesting. This was our first Windows binary that we had to look at with Ghidra, so I thought that was pretty fun. But yeah, so if you guys like this video, you want to see more of this type of content, hit the like button. I really appreciate that. If you have a question that maybe there's something that was unclear, or if you just have a question about just general what I was doing, leave your question in the comments below. I'm usually pretty responsive in there. If you want to see more of this type of content, do not forget to subscribe, hit that bell icon to notify when the videos go live. See you guys in the next one. Peace out.